In this set of videos, we'll be solving rational equations as well as work problems. And two things we want to be thinking about when we're solving rational equations. Number one, we want to be thinking about the magic number. And the magic number is just the lowest common denominator of all of the denominators. And with a little bit of work, you could see that the lowest term, I should say the lowest term that all three of these denominators go into, divide evenly into, would be 3b squared. And if you can identify that lowest common denominator, then your work is basically half over. And the other thing we want to be thinking about is, as it says here, to remember to check for extraneous solutions. What we want to do here is identify the excluded numbers. So if you remember the excluded numbers from the last lesson, all you have to do is you have to set each of the denominators equal to 0. And as you can see here, the excluded numbers, let's call them, we'll just identify them as possible extraneous solutions. Beware of these numbers would be b equals 0. So if by chance you solve this equation and way down here you get b equals 0, then you look back up here, you're not allowed to plug in b equals 0 into any one of these denominators because it would make the denominators equal to 0. So that would be an extraneous solution. If by chance we happen to get b equals 0, that would be an extraneous solution, meaning we can't use it. It would be an extra solution. So we have to just be on the lookout of that. So for that, and identifying that up front and writing it down. If we remember to look back at that, then we will save ourselves a little bit of hassle here. So what I want to do is rewrite this equation, and rewriting the equation now allows me to have some space to the left and to the right. This magic number is what we're going to multiply every single one of these terms by. So we're going to multiply both sides of the equation by 3b squared. And the main goal initially when you see fractions in an equation, which every time you have a rational equation you will have fractions, you want to get rid of the fractions. It makes things a lot easier. So in multiplying every single term by the lowest common denominator, what happens is all the denominators will go away, meaning they'll divide evenly into that, so we won't have any more fractions, and it's much easier to solve equations without fractions. So just to be clear here, I want to make sure you understand what it means to multiply every single term by the lowest common denominator. When you have 3b squared on the outside of the set of parentheses here, you're going to distribute the 3b squared to both of the terms inside the parentheses. And so this might look a little bit complicated, but actually if you write everything down and do the steps as I'm showing you, your life will be a lot easier. Now when you it'll look a lot better here in just a minute. 3b squared is the same as 3b squared over 1. Sometimes it looks better when you multiply a fraction by a fraction, so if you don't have a fraction, just make it a fraction. 3b squared, like I said, is the same thing as 3b squared over 1. Now, when we're going to multiply these two fractions together first, and as we just finished this past week, we know that when we take one rational expression multiplied by another, and we have a multiplication symbol in here, we can cancel any term from the top and bottom. So if you see the same factor on top as you do on the bottom, you get to cancel it out, because 3 divided by 3 is 1. And we have b squared over b. If you remember, that's b times b over b. Well, we can cancel one of those b's, and we end up getting, when we multiply these first two fractions together, we get a b and a 4 up top, and we get a 1 times a 1 down on the bottom, so that's 4b. These two fractions multiplied together give us 4b. And then we do the same for the other sets of fractions. 3's cancel, the b squareds cancel, and you're left with just 1. So 4b minus 1 equals, and over here we see that the b squareds cancel, and all we're left with is 3. So if we add 1 to both sides, we end up getting 4b equals 4, which when we divide both sides by 4, we know that we get b is equal to 1. And then we check. We always check. We look back at what we initially identified as that extraneous solution, possibly, and this doesn't match that one, so b equals 1 works. B equals 1 would make this equation true, so check, and we're done.